I'm going to talk through this draft on number 1 and just give some comments and feedback on what I'd like to see in the final draft. So this is typed up and it looks really nice and easy to read, easy to follow. Everything's spaced nicely so it's not overwhelming or a lot of text. So I like how that's looking. And so I'm just going to read through and make some comments here. So it's saying in order to prove the biconditional, we need to prove that if x cubed is irrational, then x is irrational, and if x is irrational, then x cubed is irrational. So maybe just say in order to prove this biconditional, or you could just even write out the whole statement in order to prove x cubed is irrational if and only if x is irrational. We need to prove these two conditional statements. Or you don't even really have to include that sentence, but it's nice to set up the proof for your reader, so that's no problem. And then instead of using contrapositive, let's say using proof by contraposition, we can show that if x is rational, then x cubed is rational. So this is nice. I see what you're trying to say here. However, I think it's more important here because what you're trying to actually prove is you're trying to prove this x is rational implies x cubed is rational, but what we're trying to prove is that if x cubed is irrational, then x is rational. The irrational, excuse me. And so we're proving this by proof by contraposition. So you're setting it up and saying, okay, this is not what we're actually going to prove. We're going to prove the contrapositive. So by definition of rational numbers, x is expressed as the ratio between some integers a and b, where b does not equal 0, and a and b do not have a common factors. Okay, so and I think that we can remove this portion and just rewrite x as that quotient. Okay, so thus we have, let's put a period here, x cubed equals that looks good. It follows that a cubed and b cubed are integers and b cubed is non-zero. Period, let's capitalize. Therefore x cubed is a rational number. With this example we showed that you can just say, we don't need this part. We have shown that if x is rational, then x cubed is rational. Since this was a proof, and again, you can remove that part and just say we can conclude that if x cubed is irrational. So that's totally sound, totally good of that conditional. Now, we're going to have an issue with this conditional, and the reason is this conditional is also actually false. We're trying to show that if x is irrational, then x squared is irrational. So just to give you a little hint here, we have disproved that if x is irrational, then x squared is irrational. And so to disprove this conditional statement, it's going to be pretty similar. So if you remember back to this conditional statement, we said, what if x is equal to square root of 2? Well, then x squared is equal to 2. So this disproves that conditional statement. So can you find similar to this, right? This is a square root. Now maybe we look for a cubed root, right? So I'm going to say hint cubed root. And so actually, even though this is an if and only if one of the conditionals is false, then the whole statement is false. It's okay to leave in this first proof of the conditional if you want, but really if you want to disprove something, if we know it's false, then we only need the one counterexample. So you really only need to include the counterexample that we're going to talk about that I'm mentioning here, similar to this square root of 2 example. So I hope that helps with that one. Let me know if you have questions about that.